This is part 5 of your scavenger hunt, and we're going to explore end behavior of quadratic functions. As you follow along, make sure you are filling in your note sheet. I want you to use your calculator to look at the following graphs. Sketch a graph next to each function on your notes page. Pause the video now so that you have time to sketch your 5 graphs. Let's check your answers. These graphs are more accurate than what you are required to draw, but they should have the same qualities as your sketches. And here's 4 and 5. So let's compare those 5 graphs. If you had to group these functions, what 2 categories could you separate them into? Remember that the standard form of a quadratic function is f of x equals ax squared plus bx plus c. Look for key features of the graphs, maybe key features from your functions, and see if you can make 2 different categories. Here's how I would group them. If you look, 3 of your functions have that a is greater than 0, meaning your leading coefficient is a positive number. And you have 2 functions where a is less than 0, meaning your leading coefficient is a negative number. Take a second and look at their graphs again. Something else should be similar. So what should we notice? Again, that if a is greater than 0, it's a positive function, and if a is less than 0, you have a negative function. And so your graph should open up if a is positive, making like a smiley face, and your graph should open down if a is negative or less than 0, which would be like a frown face. So let's actually define end behavior. The end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. And as we start to look at our graphs, just remember that the x-axis runs left and right. So we'll always look at the x-axis first, followed by then what's happening to our f of x, which really is just y equals. So here's our first example. We take our f of x equals x squared plus 2x. You've already looked at this function from our previous slides. And so I'm going to first look at our side when x is approaching positive infinity, meaning it's my positive numbers on my x-axis. So as x approaches positive infinity, what's happening to y? So we take our function, and because we know that it touches the edge of our graph, we assume that the graph goes on forever. So I would suggest that you pick any number that's a positive x value to substitute in for x. Pick a really big number. For the sake of these problems, I'm going to use 20. And so if I substitute 20 in for my x, we'll see what happens to y. When you work that out, you should get 440. And so what we're looking for is that answer a positive or negative number? Because it's positive, as x approaches positive infinity, because I'm on the positive side of my graph, y approaches positive infinity, because my answer, my result, was positive. And here's how you write that with your notation. I know it looks weird, it's not that bad. As x approaches, the arrow means approaches, positive infinity, y approaches positive infinity. So let's look at the other half of the graph. And so now we're going to look at our side of the negative infinity with our x's. So as x approaches negative infinity, y approaches, and we're going to figure that out. So take your same function, and since last time I picked positive 20 because I was on my positive side, this time I'll use negative 20 because now I'm on the negative side of my x values. Again, you can pick whatever value you want, just make sure it's a very large number or very small number, depending on if you're on the positive or negative side. And so when I substitute that in, my result is 360. Again, my answer is positive, which means as x approaches negative infinity, because I'm on the negative side of my x values, y approaches positive infinity because my y value is positive. And here's your notation. So as x approaches negative infinity, y approaches positive infinity. I used a negative x value to fill it in. That's why I have a negative. And my answer was positive, which is why I have a positive. So just to summarize it, here's all you'd have to write as your final answer. So let's try it again. Our next function is negative 3, g of x equals negative 3x squared plus 4. And as x approaches positive infinity, y approaches. So see what you can do to fill in. You can use the same number or use something different. I'm going to use 20 again. So I take my function, and wherever I see an x, I'm plugging in my 20. And so I get a result of negative 1,196. So that means as x approaches positive infinity, again, because I'm on my positive side, my y is going to approach negative infinity. As x approaches positive infinity, y approaches negative infinity. And so we'll do it again on the y side. And as x approaches negative infinity, y approaches, we're going to figure that out. And so you can see, just like we did last time, we put in the negative 20, and our result is negative 1,196. So as x approaches negative infinity, y approaches negative infinity. It's okay for them both to be negative. And so this is how we'd write our answer. And again, just to show you the final result of both of them together, here's what you would have. It doesn't matter if you start with your positive or negative side first, total personal preference. So take these three and try them out. Again, pause the video so that you're able to work them out, and then we'll test our answers together. So here are your results. What I also want you to notice is where you have all the y's. Remember, y can be written as h of x or g of x or f of x. It depends on the function that you're using. So that's just a notation. We could change all of our y's to be whatever the function notation was in our examples. So we'll also practice that when we do some examples together the next time. But again, all of the y's could either be the h of x, g of x, f of x with your notations. So now you've learned your part 5 on end behavior, so it's time to move on to part 6.